right. Barker, thanks for the comprehensive introduction. Appreciate the kind words. Hi, everyone. Good morning, and thanks for coming to this talk. In the next 45 minutes, I'll spend explaining a solution pattern that you can build with combining several technical pieces together. So that includes Apache Pinot, Redpanda, and Apache AP6. So it's going to be a good ride. So let's get started. So I know Barker already gave me an introduction, so let me add to that. I'm coming from a background in big data, event-driven architectures, and those kind of things, API management. And I belong to this old world of middleware, enterprise integration, API management, those kind of things. I used to write a lot about these things, and you can find my content on platforms, including LinkedIn, Twitter, Medium, and etc. So if you have any questions or if you have any thoughts about my talk, please feel free to reach out to me on these platforms, or please feel free to ask me any questions. All right. So about this talk, so why did I pick this topic? So there are several reasons, The reason being, I want to tell you a story about, combining different technological experiences I had during my past, working at these companies. As you see, I spent some good years of my career working for WSO2 as a solutions architect. WSO2 is a full lifecycle API management platform. So there I got the hands-on experience on API management and enterprise integration. And then I changed my gears and I joined StarTree as DevRel. So that gave me the opportunity to work with the smartest minds in Silicon Valley. And then I got the opportunity to learn Apache Pinot and understood the real-time analytics spectrum in broad strokes. Today I'm with Redpanda, trying to evangelize the importance of fast data around the world to make the world a better place. So about this talk, so this is going to be a blueprint rather than showing you a fancy demo. So I'll present you a blueprint to build a scalable and reliable API usage tracking system by combining Apache AP6 as the streaming data, full lifecycle API management platform, and then we have Redpanda as the streaming data platform, and then we have Pinot as the serving layer. So we'll take this as a design exercise. So if you are coming from architecture background, focusing on solutions architecture, enterprise architecture, or maybe even data engineer or something, this talk might benefit you. Again, sorry, there's no demo, but we'll take this as a blueprint. So let's start by talking about APIs. Raise your hand if you have heard of APIs. API management? Thank you. That makes my life easier. So I know you as developers, so we already know about these APIs, microservices, application programming, those kind of things. So I just wanted to give you a refresher on these things so that I can set the stage for the rest of my talk. So basically, API is a business capability delivered to consumers over a network. So what do you mean by delivered over a network? So basically, what we are talking about here is a digital resource hosted somewhere else, and it is consumable over some kind of a network protocol. So this network protocol can be something like HTTP, right? So this is where we see RESTful APIs and GraphQL APIs sort of things. And it could be something like asynchronous message-oriented protocol, something like MQTT and AMQP. We work with digital business all the time, and in a digital business, APIs allows the programmatic access to these resources, business operation. So programmatic access in the sense, there's no human interaction in the loop, right? So, and these business operations can be something like performing a simple task, like creating an order, making a payment, or transferring funds between two accounts, right? And it could be something like performing a computation and returning output to the caller, the consumer. This is like generating an image using a machine learning model, right? In a typical API setting, you can see 3 parties involved. As you can see, in the far right-hand side, you can see the back-end system. So these are the systems that run the business operations. So they could be microservices, mainframes, virtual machines, could be anything, right? And in the left-hand side, you can see the consumers of these systems. So this could be end-use applications like smart or mobile application. It doesn't matter. Most importantly, the APIs sit in the middle, and their job is to proxy these consumers from these back-end systems. So basically, APIs help consumers to prevent this internal complexity of back-end systems reaching the consumers. And also, businesses can use API as an abstraction so that unwanted consumers can't get into these kind of internal details of the business systems. In a production setting, we typically use full lifecycle API management platform to manage APIs at scale. So this is where we see API gateways and these kind of developer portal and so on. Right. So there are so many full lifecycle API management platforms in the use. I mean, the name is so long, full lifecycle API management. But the idea behind this, it's a packaged product. It comes with different components inside. So each component is dedicated to perform some kind of a task of API lifecycle management, something like creating API proxies and deploying and engaging runtime policies as well. For this talk, I decided to use Apache API6 or API 6 for the demonstration, for the reference. So because it's open source and I really like working with it because it's so easy. But having said that, there's a vast ocean out there. So you can see the vendor space of API management lifecycles, vendors. So you can work with, you can adapt the solution to work with any of these vendors out there. All right, that's about APIs. So I just wanted to give you a brief refresher about APIs. So basically, I can talk all day about full lifecycle API management, API governance, API business, and so on. But that's not our goal today. So we are here to talk about how to make money with APIs, or in other words, API monetization. Most importantly, we'll design a system to track the usage of API traffic across different consumers and how to make it reliable. Just to give that into perspective, let's imagine this fictitious website, real estate valuation application. So this is a real estate valuation application. So this has a web UI. And this company offers its customers, like homeowners, this UI, so that homeowners can input their important information like postcode, bedroom, and those kind of things, and they can get an instant valuation to their houses or properties, right? So this sounds trivial, but underneath there can be like lots of complexity involved, like lots of statistical data, big data, and those kind of things. To scale these things, the company decides to isolate the valuation engine and surround it with the API layer. So, and then these consumers, like first-party and third-party consumers, they can consume this valuation engine through this API management platform. So in front of that, there's an API management platform. The way we do that is they create API products. They create APIs, and each API is treated as a product. Product in the sense it has its own life cycle, price tag, and etc. So who are the potential API consumers here? So this could be real estate companies, right? Because we are doing a valuation, these companies can provide accurate valuation figures for home buyers. So when they render these house prices in the websites, they can see they can get an instant valuation and see this house price is undervalued or overpriced. And then banks will use this service before approving housing mortgages. And then insurance providers for content and home insurances. And then governments for easily calculate property taxes. So as you can see, the consumer space is getting expanded. Now the question is how this company would make money with APIs. So this is where we are trying to solve the business problem. So basically, like I said, this company sells its APIs as products. Product in the sense each product has a price tag. So in our context, price tag is the subscription tier for this API, right? So for example, subscription tier is like a quota that is given to an API consumer that allows the consumer to make a fixed number of API requests per month. For example, we can offer the valuation API over 3 subscription tiers like bronze, gold, and platinum, right? Bronze being the lowest tier, so it will allow, let's say, like 10,000 requests per month. And then we have gold with 100K, and platinum, given that it will give you unlimited API access. You can assign different pricing levels for these subscription tiers. And then the company, if these consumers exceed their limit, monthly quota, we can either throttle them out or we can charge them for excess usage. And at the end of the month, the valuation company can charge these consumers based on their usage. So that's the business problem we are trying to solve here. In order to do that, we need to find an efficient and reliable way of measuring API usage for each consumer, right? So that's the business problem. I mean, this is like a use case, but this can be related to your problem, real-time analytics problem in any way. So let's try to dig in. Before I get into the details, let me walk you through a couple of design decisions I would make as an architect in this solution. The first thing, so I'm trying to reverse engineer things here. So what are the metrics or KPIs I would expect from this solution? So there are 2 metrics in particular. First one is the API traffic volume. That means I'd like to see the API invocation across all the consumers as a total figure. Or I'd like to see it as a breakdown per each consumer. So I'd like to have them plotted in a nice line chart so that I can easily figure out the patterns, right? And then secondly, I'd love to see the latency. Latency in the sense I'd love to see the P99 or some kind of a SLA latency so that I can easily figure out which API are sluggish or slowest so that I can do some actionable things like allocating more resources or scaling them out. And then in addition to that, I'd like to see how many unique users getting signed up. So this is good for product growth perspective. And then I like to see geographical usage traffic information so that I can see which region I'm getting more traffic from so that I can optimize my resource usage. And then obviously error count. That means if I see an API with so many errors, that means I can decide this backend is having issues so that my operations team can do something actionable. So end of the day, I would like to see this kind of visualization, this kind of a dashboard, everything, collating everything together. You can see single-digit metrics, line charts, pie charts, and everything. So this is the destination we need to reach. So how do we get there? Let's figure out. And the second decision is to whom I'm going to serve these metrics. So these are going to be my stakeholders. So there will be 3 parties. First one being my customers and partners. So customers as in, this could be the banks, insurance providers, and those kind of parties I mentioned above. So their need is to see how much quota has I consumed so far for a given month. It's like, if you have bought a data plan in your mobile provider, it's like how much data I have remained in my monthly quota. It's like that. And they would like to see some getting reminders when they reach certain thresholds in their thing. Secondly, I have the operations team. So these are the very people that takes care of this API management infrastructure. So I'm talking about DevOps and SRE teams here. They'd love to get paged and monitored when things are getting not as expected. And finally, I have the API product team. So this could be a different BU with their own P&L. So they take care of these API products. So they take the accountability of things. So basically, they want to do sort of ad hoc queries on these metrics. So they want to do experimentations, A/B tests, and those kind of things. So likewise, we have very diverse set of audiences we need to serve. Sorry. And then the third decision is whether to make it batch or real time. So it's like the most important question here. I would like to see an 80 to 20% distribution split between real time versus batch. I'd like to see 80% real time because, if you remember the keynote done by Kishore, the data loses its value as the time goes by. So we need to make sure we derive insights and act upon them whether they get expired. So I'd like to see, first of all, real-time usage alerts for consumers. For example, if a consumer is reaching a certain threshold of their quota, let's say like 75%, I need to send them some kind of a reminder or a notification so that they can take some action. Maybe their API key has been stolen and some rogue user has been making the call. So that way we can block their access and we can figure out things like that. If they are running out of the budget, they can take some kind of corrective measures. And secondly, the operations team would love to see the health information of the APIs. If the average latency is getting high, there's something wrong with the backend. So they will do some corrective measures. And then I'd like to complement this real time with batch processing because not everything has to be real time. Because there are certain use cases that ideally carved out for batch processing. For example, we can send the monthly usage-based billing reports with batch processing. There's no harm doing that. And then we can do API incident reports weekly and those kind of things. So we can have a healthy balance between this batch and real time by combining necessary features in the solution. All right. I think I have reached the halfway point of the talk, and this is where I'm going to talk about the solutions architecture. So this is the blueprint I'm going to present to you. I know it's a crowded diagram with lots of bells and whistles. So let's try to break it down into several layers, and I'll walk you through each layer in detail. So this is a layered architecture. It's like a layer cake. So at the top, we have the operations layer. So this is where the usual business happens, right? So this is the API management infrastructure. The API gateway. And then we try to find a touch point in the API gateway so that we can tap into this east-west traffic, and we can get them into the processing layer. And then we do the processing. And then in the serving layer, we serve that traffic to the stakeholders. So that's the plan. Before moving forward, I'll quickly walk you through how a typical full lifecycle API management platform works. As I mentioned earlier, these platforms have different components. So they come up with bundled components. So each component has different purpose for doing during their API lifecycle journey. For example, we have this publisher kind of component. So their job is to design API proxies. So this designing can be happening visually, or it can be done in you can let the user to do some kind of YAML, and then it can be converted into a proxy. And then we have the API gateway. So this is where you deploy these API proxies. Once you deploy it there, this gateway will act as a central point of receiving consumer traffic to your backend services. This is where you are going to engage security policies like O2, OpenID, and then you can also enforce traffic shaping policies, rate limiting policies, and those kind of things. And then we have the developer portal. So this is where you market your API products. So this allows the developers to discover your APIs, try them out before making a decision to subscribe or not. I mean, there are lots of details in this architecture, but the only component that we are going to focus today is the API gateway. All right. Our first task today is to find a touch point so that we can collect these HTTP requests that are going back and forth between backends and consumers and bring them to some kind of analytics data store in real time, right? So our task is to build this pipeline possible. Right. So what kind of information we can collect from there? So this is a sample payload I can collect from Apache AP6. You know, it's a bit crowded, but you can clearly see some kind of critical information like upstream latency, the responses headers, start time, and those kind of things. So this information will be dimensioned in the downstream data application. So we'll query this information when we go to the serving layer. So that's the end goal. Right. So now the path is clear. So we are trying to write from API gateway to the database. Seems like simple, right? But it isn't. But the thing is, writing directly from the gateway to the data store is not recommended because you know, there can be some consideration. Because this will introduce a coupling, tight coupling between the API management system and the database. If you do that, these systems will have to, it will be hard for these systems to evolve as the time goes by. And then, in addition to that, this synchronous coupling will introduce a temporal coupling. That means both systems must be available at the same time in order to become operational. That means if you need to take down the analytics database for like maintenance tasks, you have to bring up another instance like HA. That is costly. And also, this introduces this synchronous write problem. Sometimes there can be like traffic spikes in the API gateway because of these seasonal traffics, and there can be like other reasons. So when that happens, there will be a much more pressure put into the analytics infrastructure, in addition to the pressure coming from the consumers, queries. So we need to make sure that database, analytics database is not bottlenecked. Because to solve these problems, what we are going to do is, we are going to put a buffer in between. So this is where we bring in a streaming data platform. And this is where you meet Redpanda. Has anyone heard of Redpanda before? Nice. So that's good. So basically, Redpanda is a streaming data platform. If you haven't heard of Redpanda, it's a streaming data platform, API compatible with Apache Kafka. That means you will find all the familiar concepts in Kafka in Redpanda as well, that including topics, partitions, consumer groups, segments, logs, everywhere. That's there. And you can also bring in your existing Kafka producers and consumers to Redpanda seamlessly without even changing a single line of code, because Redpanda guarantees the read-write compatibility built-in. Although Redpanda speaks the same language as Kafka, there are some drastic differences in its architecture. Like it's written in C++ rather than depending on a JVM, and that gives Redpanda more edge on the performance, and it's designed for modern hardware as well. Also, it adds simplicity to deployment. It comes with critical features of streaming typical Kafka deployment in one runtime. So you can, when you spin up a Redpanda broker, you will find the schema registry, HTTP proxy, the Raft implementation, and everything, and the broker, everything in one process, so that you don't have to deploy them separately. And also, it's a developer's best friend. So you can see it comes with a web UI called Redpanda console. So you can administrate your Redpanda cluster from there. Like you see, you can debug your streaming data. You can even see the payloads without using third-party tool. And then you can engage and create ACLs. And that will make your life more easier. All right. Now that brings us the question. You might even ask me, do I need to have Redpanda in my architecture? Is it mandatory? Absolutely no. I mean, alternatively, you could use Apache Kafka as well. I'm just laying out you a few additional options here. So Redpanda makes sure that whether you have Kafka or any other Kafka flavor, it will work transparently with Redpanda as well. OK, now we have this decoupling in the middle. So we now have streaming data platform in the middle, and that will add more benefit to the architecture. That means you can take down the analytics database at any point, and you can you can take it for upgrade, and then once you bring it back, it can consume from where it left off. And that adds the benefits of asynchronous writing. And that also adds the benefit of evolution, right? That means, if needed, you can define a standard format for your API payloads and write it into a Kafka topic or Redpanda topic. That way, if you decide to switch from API6 to different API vendor in the future, you don't have to rewrite your analytics infrastructure. That's standardized. And then lastly, this decoupling adds a good pub-sub architecture to your system. That means you can reuse these API payloads into different, repurpose them into different use cases. Like you can route them to Snowflake or Databricks for different purposes, like other use cases like that. All right, now we have this thing in the middle. We need to figure out how do we get the API request from API6 to Redpanda. That's the next question. Fortunately, we have this Kafka sync available in API6. So that's why the reason I chose API6. Of course, others have different options, like Kong also has Kafka sync as well. And then few others, they write this API request into log files so that you can tail the log file and bring it to Kafka as an alternative. But I like this approach because it's less complicated. So because this Kafka sync is there, we can reuse it for Redpanda because of the API compatibility. So what you see in the right-hand side is the sample configuration, a proxy configuration, where this is where you do your Redpanda configuration. All right, now we have figured out the ingestion part. Now it's time for analytics database. So what kind of database we should use? Should I go for a OLTP, data warehouse, key value store, or document store? This is the problem we need to solve here. So basically, there will be 3 key design decisions I need to keep track of. First one is, I need to have a higher amount of data freshness. That means whether the user queries this database, I need to make sure that this database returns the most fresh and accurate information as much as possible. That means this database must be able to perform streaming data ingestion, and we are not talking about batch loading here, right? And then the queries must have low latency queries, low latency things, because there can be user-facing queries coming from the consumer dashboards. Also, the QPS, or query throughput, should be high. So this is why we decided to go with a real-time OLAP database. So this is why we are here with Apache Pinot, because it checks all the boxes for these requirements I have laid down. So what is Apache Pinot? I'm pretty sure you know most about Apache Pinot, because Apache Pinot is a real-time distributed OLAP database, which can consume data from streaming data sources as well as batch data sources. And also it offers low latency and high concurrency query support, which is ideal for our serving layer. So if you need to know more about Redpanda, Apache Pinot, you can learn it from the best. So go check out this from Tim Berglund. All right. Now we have our complete data pipeline from end to end. So, as you can see, the data flow begins from API6 and it reaches to Pinot through Redpanda. And you can see an optional component in over there. It's called stream processor. So do I need a stream processor in the architecture? Why should I use it? So basically, my opinion is it's not mandatory, but it's nice to have based on your exact need. Most of the time, we might need to do some kind of data cleansing before we push it down to downstream systems, like scrubbing PIs, sensitive information. For example, if you are collecting API payloads from logins or some kind of things, there can be PIs like user's email address, phone number, and those kind of things. So most of the time, you need to scrub them before you push it down to third-party system. So this is where you need some kind of stateless processing. But with Redpanda's these WASM transforms, you can do that without a stream processor. So that's the thing. And then secondly, you might need to do some stateful stream processing things like window-based joins, aggregations, and things. But with Apache Pinot's latest release, Pinot can join tables. So I don't see this is like a strict requirement for having a stream processor. But if you want to do some kind of a trigger-based trigger external workflows, like triggering an email based on the condition, those kind of things, you might consider a stream processor like Apache Flink or any streaming database like TimePlus, Rising Wave, and those kind of things. All right. This is about the final layer, serving insights. So Pinot belongs to the data infrastructure layer. And not all stakeholders going to access Pinot from for their day-to-day activities. So there should be some ways that we can bring out the insights generated in Pinot to a presentable manner. So this is where we need serving insights. For customers and partners, they need to have real-time dashboards, like I showed you. So this is where we are going to use Pinot's Python drivers and other things. And then the operations team would like to use some kind of monitoring and full-text search indexing. So this is where we are going to use Pinot's indexing features. And for the product team, they would like to run ad hoc queries. That means the query pattern is not predictable. If you consider with a dashboard, you can see it's like a templated query. The query pattern is already determined, so you can use smart indexing features like StarTree and other good indexing, JSON indexing, those kind of things for that. So when we talk about this visualization and BI, if you are building your dashboard with Python, you can use the PinotDB Python driver there. You can also pair it with Streamlit, which is a Python-based visualization framework. Talking about Python, you can also utilize Apache Superset, which is a BI product. You can use custom dashboards with that. And then if you want to do some kind of Java-based processing, so Pinot provides a JDBC interface and also ODBC as well. So you can bring in your Tableau and any Grafana or any other things for exploration. For ad hoc querying, you can reuse the Pinot Query Console, which I find very useful and effective. And alternatively, I just like to mention here, if you want to do some kind of interactive querying on Pinot Insights, you can use the Jupyter Notebook. So you can find this talk from Hubert from StarTree. So yeah, he has done a real cool demo showing how to query Pinot from a Jupyter Notebook using Python. It's a really nice one. This is good for analysts and data scientists to get into experimentation. And then, like I said, batch workloads. Like I said, we have 20% of batch workloads. So Pinot can satisfy them as well. You should consider putting Pinot together with query federation engines like Trino and Presto, so that you can do batch pipeline. So Trino has these nice connectors for Pinot has these connectors for Trino and Presto, so you can pair them and do the batch things going on. So what should be your implementation plan? If you are rolling out this project, I can quickly summarize. You get the Kafka or Redpanda cluster first, create topics, define ACLs, and then configure your Kafka sync in Apache so that we know how to tap into this data. And then create Pinot schemas and tables. You can get the real-time or hybrid tables created, and you can get them to ingest from this Kafka topic. And then based on your need, you can engage a stream processor to massage your data, scrub sensitive information, and then finally, you can implement your own serving layer. So this could be a dashboard, or it could be an event-driven microservice based on your need. I think we are a few minutes short from timing out, so just let me quickly recap what I have discussed. So basically, I discussed a solution pattern for a real-time analytics pipeline. So data origins from some kind of operation layer, and then it flows through Redpanda, and it adds this decoupling and asynchronous writing, and then we compute the metrics and store them in Pinot. And then we have different serving layer options. So based on your need, you can reach out to Pinot with your serving layer option. So that's the solution pattern. So the key takeaway is that if you have some kind of a similar use case, you might as well reuse this or repurpose this use case to get your thing done. Only thing missing here is I haven't stressed much about the stream processor. It could be Apache Flink or any streaming database down there. All right, that's it. So if you need to learn more about Redpanda, you can check out Redpanda University. So that's a good place to learn about Redpanda. And yeah, thanks for joining. Thanks for being here until the end. If you have any questions, I can take a couple of questions.
Questions?
Yeah, for the stream processing part, what specific API metrics you need, using streaming processing to generate some metrics?
Sorry, what?
Because you have two parts. One Pinot, one is Redpanda
yes.
stream processing, right?
Yeah.
So my question is, what specific features or metrics that leverage stream processor to analysis? Yeah.
That's a good question. I think I briefly mentioned that. Yeah. So if you have like event-driven workflows, like you need to trigger some kind of a business use case based on a change in data. It's like if the consumer is reaching like a halfway of 50% of his monthly quota, maybe we can trigger an email or send an SMS or some kind of thing. And then you can also do some kind of anomaly detection. That's a real good use case for stateful processing. For example, if, like I mentioned, if the consumer key and secret has been stolen, and if you can see like frequent invocation, then you can flag it like a anomaly, and then you can maybe blacklist or block the consumer key forever. That's good.
So this is very good for the most likely it's the monitoring case, like
exactly.
So the DevOps, who running this, they need to be notified about some bad thing happens, or
exactly.
predict some bad thing happens.
Yes.
Okay, thank you.
No problem. Yeah.
So because Kafka is with Java, and Redpanda has been done with C++.
Yeah.
So that means you have eliminated garbage collection and so on. So do you have any performance comparison, how Redpanda is better than Kafka?
Yes, that's a really good question, very timely question. So this is why, actually we have done public benchmarking, and we did performance benchmarking. And the results you can find in a public blog. So what you do is you can go to redpanda.com, and there's this section, you can find the publicly available comparison. Simply, you can just Google Kafka versus Redpanda, and you will see that in the first result. And then, in addition to that, we provide you a benchmarking kit so that you can run the benchmark yourself to cater to your own workload. And that way, you can see the TCO comparison as well as the performance comparison. So there are like different ways we have done the benchmarking.
Can you go back to the
Solution? Okay.
Yeah. So
Right.
in this case, basically in the operational layer,
Yeah.
Generally the architecture pattern that we generally do see in stream processing, where Redpanda or Kafka, which are getting data from different operational systems,
Yes.
like OLTP database via
Exactly.
change data capture,
Right.
or maybe some other sources.
Right.
But in this case, actually, the data is being received from API gateway.
Gateway. That is correct.
So does that mean that how Redpanda is going to get the data from the API?
Yes. So basically, Redpanda provides the Kafka Write API. So you can actually, in this case, the API6 has this Kafka sync. So it has this Kafka SDK inside. It is embedded inside. So it can do the writing or the publishing of the things. Alternatively, it's good that you mentioned that. Alternatively, you can tail the API, the gateway log file, so that you can get those files, those records. So the bottom line is, Redpanda supports both read and write interfaces as much as you would deal with any Kafka broker. So you will see the fetch requests and write produce requests, everything as identical to Kafka.
So it's just going to write something in the Redpanda topic.
Yes.
Okay.
You could use the HTTP proxy as well, but given that the concurrency and the latency of the situation, I would rather use TCP-based Kafka protocol here. But if your client is not, if it is not Kafka friendly, you might as well use HTTP proxy there as an option. I think if there are no questions, I think we can probably wrap it up for lunch. Enjoy your lunch. Thanks for coming.